tempat impian dan potensi tak pernah berhenti bertumbuh.
Universitas Terbuka merupakan perguruan tinggi negeri ke-45 di Indonesia yang juga merupakan pelopor dan inovator pendidikan jarak jauh di Indonesia. Dalam upaya untuk terus meningkatkan pendidikan jarak jauh yang berkualitas dunia, layanan Universitas Terbuka didukung oleh 39 kantor daerah yang tersebar di seluruh Indonesia dan 1 pusat pengelolaan luar negeri. Fakultas Sains dan Teknologi Universitas Terbuka merupakan fakultas dalam bidang sains dan teknologi yang bertujuan menghasilkan lulusan yang kompeten, mandiri, dan kompetitif di bidang sains dan teknologi. Awalnya, fakultas ini dinamakan Fakultas Matematika dan Ilmu Pengetahuan Alam. Kemudian pada tahun 2019, berdasarkan Permenristek Dikti, berubah penamaan menjadi Fakultas Sains dan Teknologi atau FST.
Selamat datang di Fakultas Sains dan Teknologi Universitas Terbuka. Universitas Terbuka atau disebut UT menyelenggarakan proses pembelajaran secara jarak jauh dengan menggunakan berbagai media teknologi informasi dan komunikasi. UT sebagai institusi pendidikan tinggi berkomitmen dalam menyediakan akses pendidikan yang fleksibel, terjangkau, berkualitas, dan berdaya saing luas tanpa batas bagi seluruh masyarakat Indonesia. UT akan terus berupaya untuk meningkatkan mutu dan daya saing di kancah nasional maupun global. Fakultas Sains dan Teknologi atau disebut FST merupakan salah satu fakultas di UT yang dapat dipilih sebagai jembatan untuk mencapai karir tertinggi, profesional, dan pribadi yang berkarakter, sehingga dapat berkontribusi terhadap kemajuan bangsa Indonesia. Perkembangan mahasiswa FST yang meningkat dari tahun ke tahun menunjukkan kualitas dan kepercayaan masyarakat terhadap FST UT yang tumbuh positif. FST menawarkan 8 program studi jenjang sarjana di bidang sains dan teknologi yang meliputi program studi S1 Biologi.
Program studi S1 Biologi mempersiapkan lulusan dengan penguasaan mendalam terhadap prinsip-prinsip biologi untuk mengoptimalkan potensi keanekaragaman sumber daya hayati Indonesia dengan menghargai kearifan lokal dengan didukung literasi digital, kemandirian, dan etika profesional yang kuat.
Program studi S1 Matematika.
Program studi S1 Matematika menghasilkan pembelajar mandiri yang dapat menerapkan konsep dan prinsip matematika dalam menyelesaikan berbagai masalah matematika dan terapannya. Lulusan program studi S1 Matematika FST UT banyak berkiprah sebagai praktisi di bidang pemerintahan, industri, dan organisasi kemasyarakatan, asisten peneliti maupun akademisi.
Program studi S1 Statistika.
Program studi S1 Statistika dirancang untuk menghasilkan lulusan yang memiliki kompetensi akademik di bidang statistika dan penerapannya, serta mampu berpikir kritis, analitis, dan sistematis, sehingga dapat berkiprah di sektor industri, pemerintahan, maupun penelitian.
Program Studi S1 Perencanaan Wilayah dan Kota. Program Studi S1 Perencanaan Wilayah dan Kota atau PWK memberikan pengetahuan dan keterampilan dalam menyelesaikan berbagai permasalahan sosial, ekonomi, lingkungan dan infrastruktur dalam suatu kota dan wilayah. Program studi PWK-UT membersamai mahasiswa belajar untuk dapat menjadi seorang perencana yang handal, yang siap bekerja di berbagai bidang termasuk pemerintahan, perusahaan, maupun penelitian. Program studi S1 Sistem Informasi.
Program studi S1 Sistem Informasi dirancang untuk menghasilkan lulusan yang memiliki pola berpikir analitik dan sistematik di bidang sistem informasi yang dapat diterapkan untuk memberikan solusi terhadap berbagai masalah dalam masyarakat.
Program studi S1 Agribisnis.
Program studi S1 Agribisnis menghasilkan lulusan yang berdaya saing unggul yang berwawasan pengembang masyarakat di bidang agribisnis. Program studi agribisnis mencetak lulusan yang memiliki kompetensi sebagai wirausaha, manajer, dan pengembang masyarakat agribisnis.
Program studi S1 Teknologi Pangan.
Program studi S1 Teknologi Pangan menghasilkan lulusan yang kompeten di bidang industri pangan berbasis sumber daya lokal dan memiliki wawasan kewirausahaan. Lulusan prodi teknologi pangan dapat berkiprah sebagai manajer, wirausaha, regulatori, praktisi di bidang QA, QC, PPIC, R&D, dan bidang lainnya di industri pangan.
Program studi S1 Sains Data.
Program studi S1 Sains Data dirancang untuk menjawab tantangan zaman dan mencetak para ahli data handal di era revolusi industri 4.0. Para lulusan dibekali keterampilan ilmu statistika, pemrograman, visualisasi data, machine learning, dan big data analysis agar siap bekerja sebagai data scientist untuk menyelesaikan masalah real di berbagai sektor seperti bisnis, industri, dan sosial.
Desain kurikulum yang dinamis pada setiap program studi selalu di-upgrade dengan menyesuaikan perkembangan iptek dan dinamika pasar sehingga dapat memenuhi kebutuhan tenaga kerja profesional di Indonesia.
Fakultas Sains dan Teknologi Universitas Terbuka atau FSTUT memberikan berbagai layanan akademik yang mendukung kesuksesan belajar jarak jauh, meliputi layanan SSO MyUT, Virtual Reality, Lab Praktikum, Perpustakaan Digital. Mahasiswa dapat mengasah keilmuan dalam bidang sains dan teknologi melalui berbagai kegiatan, antara lain visiting lecturer, webinar nasional, seminar nasional Saintek, seminar internasional. Selain layanan akademik, Fakultas Sains dan Teknologi UT juga mendukung kegiatan kemahasiswa untuk mengasah soft skill dan hard skill mahasiswa melalui program kreativitas mahasiswa, program pembinaan mahasiswa wirausaha, program Merdeka Belajar Kampus Merdeka, Olimpiade, Dispor Seni, Inkubator Virtual Sains dan Teknologi, prestasi mahasiswa. Dalam mewujudkan pendidikan jarak jauh yang berkelas dunia, FSTUT telah menjalin kerjasama dengan dunia kerja serta universitas ternama di dalam dan luar negeri. Kerjasama dilakukan dalam bentuk pengajaran, penelitian, dan pengabdian bersama, serta magang mahasiswa.
Belajar di UT memberi saya fleksibilitas untuk kuliah sambil bekerja, sekaligus melatih disiplin dan pola pikir kritis. Yang paling penting, UT mengajarkan keterbatasan, bukan halangan untuk bermimpi besar. Buat kamu yang sedang kuliah di UT, percaya diri, terus belajar, dan jangan takut melangkah lebih jauh.
Berkuliah di Fakultas Sains dan Teknologi Universitas Terbuka merupakan pengalaman yang berharga bagi saya. Sistem belajar yang fleksibel memungkinkan saya untuk mengatur jadwal kuliah saya kapanpun, dimanapun sesuai dengan kebutuhan. FSTUT bukan sekedar tempat kuliah, tapi tempat membangun masa depan.
Sekali lagi, selamat bergabung di FSTUT untuk masa depan yang lebih cerah. Faculty of Science and Technology, kreatif, inovatif, kolaboratif, FSTUT,
Oke, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan, Rahayu. First of all, allow me to extend our warmest greetings to the honorable speakers. First is Professor Dr. Fatia Fatimah, SPD, SSI MPD, which coming from Universitas Terbuka Indonesia. And next, Dr. Imran Talib, which coming from the Virtual University of Pakistan. And also, we would like to welcome our honorable guest today, the rector from Virtual University of Pakistan, Professor Dr. Nasir Mahmud. Registrar from Virtual University of Pakistan, Professor Dr. Atar Azim Khan. The Dean Faculty of Science and Technology of Virtual University of Pakistan, Professor Dr. Mohsin Javed. The Dean of Faculty of Science and Technology of Universitas Terbuka, Dr. Subekti Nurmawati, MSI. The Director of Office of Research, Innovation, and Commercialization, which can call it in short ORIC, from Virtual of University Pakistan, Professor Dr. Tanvir Hussain. The Vice Dean for Academic Affairs, Dr. Sita Ali Farihati, SSI, MSI. Vice Dean for Finance, Resources, and General Affairs from Faculty of Science and Technology of Universitas Terbuka, Dr. Anda Inggit Linarni, MSI. The Vice Dean for Students, Learning Services, and Partnerships from Faculty of Science and Technology of Universitas Terbuka, Dr. Pepi Raspina Pertiwi, SP, MSI. All of the Head of Study Programs on Faculty of Science and Technology of Universitas Terbuka, especially from Mathematics Study Program, Mrs. Elin Herlinawati, MSI. Head of Department of Mathematics from Faculty of Science and Technology from Virtual University of Pakistan, Dr. Shahzad Faizi. And also Mrs. Madadia Putri Martina Sari, SPD, MSc, as our moderator. And last but not least, all of the participants of today's event. We would like to say welcome to the International Visiting Lecture on this day, Wednesday, 11th February 2026. Good morning for all of the participants which coming from Pakistan, and also good afternoon to all participants who's coming from Indonesia. And we would like to say and give a very warm welcome to all of the participants who are joining us virtually through Zoom and YouTube. And we would like to inform to all of the participants that this International Visiting Lecture is a collaborative event that proudly presented to you by the Faculty of Science and Technology of Universitas Terbuka and also Faculty of Science and Technology of Virtual University of Pakistan, with the theme of Global Trends in Mathematical Sciences, Research and Education Collaboration. First of all, I would like to introduce my own self. So my name is Safira. It is such an honor and a pleasure to be as the host for today's event. And in addition, I would like to inform to all of the participants of today's event will get a certificate, but all of the participants you gotta have to fill the attendance form that will be shared by link at the end of today's event. So, ladies and gentlemen, as we play the national anthem of Indonesia and Pakistan, we invite you to observe a moment of solemnity and maintain a respectful posture from your respective locations. Thank you. So, ladies and gentlemen, as we gather here today, let's pray together according to our respective religions and beliefs. Please start praying. Amin, 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 ya Rabbal Alamin. May Allah Subhanahu wa Ta'ala, the Almighty God, give His blessings and grant all of our wishes for today's event. So, ladies and gentlemen, let us hear a welcoming speech that coming from the Dean of Faculty of Science and Technology of Universitas Terbuka. Please welcome Dr. Subekti Nurmawati, MSc.
Okay, thank you, Ms. Safira. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, ladies and gentlemen. Best wishes to all of us. Alhamdulillahirabbil alamin. On this very fine day, we can gather in this forum, and it is our privilege that we can join in today's visiting lecture. Our Honorable Rector of Virtual University of Pakistan, Professor Dr. Nasir Mahmud, our Honorable Registrar, VUP, Professor Dr. Atir Azim Khan, Dean of Faculty Science and Technology, VUP, Professor Dr. Mohsin Javed, Director Office of Research, Innovation and Commercialization, Professor Dr. Tanvir Hussein, Head of Department of Mathematics, Dr. Shahzad Faizi, our distinguished speakers, Dr. Imran Talib, and also Professor Dr. Fatia Fatima, Honorable all of Vice Deans from FSTUT, all of the head study programs of FST, especially Head of Mathematics Study Program, Mrs. Elin Hernawati, MSI, our moderator, Ms. Madadiah, MSc, as a lecturer of Mathematics Study Program, FSTUT, respective college from Virtual University of Pakistan, all FST's lecturers, students, and participants from several partners universities who attend in this visiting lecture. Firstly, praise is to Allah subhanahu wa ta'ala for His mercy and grace. This morning, we are all able to attend the visiting lecture. On behalf of Universitas Terbuka Indonesia, it is my great pleasure and honor to welcome you to the International Visiting Lecture Webinar, a collaborative academic event between Universitas Terbuka Indonesia and the Virtual University of Pakistan. Today's webinar focusing on global trend in mathematics research and international collaboration represent more than just an academic gathering. It symbolizes the strengthening of cross-border partnership in higher education. In today's rapidly evolving world, mathematics plays a central role in driving innovation across science, technology, industry, and society. From data science and artificial intelligence to sustainable development, future of global progress, universities therefore carry a a shared responsibility to cultivate knowledge, foster research excellence, and prepare graduates who are globally competent and collaborative. The webinar highlights the importance of international academic cooperation, collaboration between institutions such as Universitas Terbuka Indonesia and the Virtual University of Pakistan demonstrate how distance and borders are no longer barriers to learning and research. Through partnership like this, we create opportunities to exchange ideas, share expertise, and build joint research initiatives that address global challenges. We hope that today's discussion will inspire new perspective on emerging mathematical trends, encourage interdisciplinary research, and open doors for sustained collaboration between our institutions. More importantly, we hope this forum will strengthen academic networks among lecturers, researchers, and students, fostering a spirit of mutual learning and global citizenship. I would like to express our sincere appreciation to the speakers and organizers from both universities for their dedication in making this event possible. Your commitment to academic excellence and cooperation is truly commendable. Finally, I encourage all participants to actively engage in today's session, ask questions, share insight, and take full advantage of this valuable opportunity to learn and connect. May this webinar serve as a stepping stone toward deeper collaboration and impactful research in the years to come. Thank you very much for your attention. Wishing you all a productive and inspiring webinar. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Once again, thank you, Dr. Nurma, for giving such a very warm welcoming speech for today's event as the representatives from Faculty of Science and Technology of Universitas Terbuka. And ladies and gentlemen, next, let us hear a welcoming speech that coming from the Director of Office of Research, Innovation, and Commercialization, or we can call it in short, ORIC, from the Virtual University of Pakistan. Please welcome Professor Dr. Tanvir Hussain.
Assalamu alaikum, and thank you very much, Ms. Safira Alisha, for the kind invitation. Distinguished guests, respected colleagues, honorable speakers, dear faculty members, and my very dear students from Indonesia and Pakistan, Assalamu alaikum, and a very good morning, and Selamat Pagi. It is truly an honor and a pleasure for me on behalf of the Virtual University of Pakistan to warmly welcome you all to this International Visiting Lecturer Program. I'm delighted to see such an encouraging participation from both universities. I could see that over 100 participants are there, so it's very encouraging. This event is not only a webinar, it represents a shared vision, a vision where borders do not limit knowledge, where digital platforms connect minds, and where collaborative research and education shape the future of science. In today's rapidly evolving world, mathematical sciences play a central role in innovation, data-driven decision-making, artificial intelligence, engineering, economics, and many other interdisciplinary domains. Events like this will allow us to reflect on global trends, exchange ideas, and explore new research directions together. I would like to highlight the today's sessions makes a very positive and promising beginning of academic collaboration. As Professor Dr. Nurmawati said, that this collaboration between Virtual University of Pakistan and the Universitas Terbuka is just you can say a new step, and inshallah it will keep on growing in future. Both institutions share a strong commitment to open and distance learning, quality education, and international engagement. This joint initiative sets a strong foundation for future collaboration and cooperation in the areas such as joint research projects, faculty and student exchange visits, co-supervision of graduate students and research, joint conferences, and capacity building activities. And I'm happy that we are having first drop of rain in the form of this webinar today, and inshallah it will continue. I would like to express my sincere appreciation to the Faculty of Science and Technology for taking this excellent initiative. My sincere thanks to the Vice Dean of Academic Affairs, Dr. Sita Farihati, Vice Dean of Finance, Resources, and General Affairs, Ms. Ingit Vinarmi, and the Vice Dean of Student Affairs, Learning Services, and Cooperation, Dr. Pepi Rospini. I'm sorry for the pronunciation differences. And a very special thanks to the Dean Faculty of Science and Technology, the Honorable Dean, Dr. Subhakti Nurmavati. Thank you very much for your kind collaboration and cooperation. And I still remember during your visit to Pakistan, we decided many things to do in coming days, and I'm happy that we are actually heading towards the what we've planned here. And inshallah, it will be, we will be having many more other programs in the future. And I also extend my gratitude to all the head of the study programs at FST UT and the respected faculty members for their continued efforts in promoting the international academic engagement. From the Virtual University of Pakistan, I sincerely acknowledge our Honorable Rector, Professor Dr. Nasir Mahmood, our Honorable Registrar, Dr. Athar Azim Khan, our Honorable Dean, Faculty of Science and Technology, Dr. Mohsin Javed, and the Head of Department, Dr. Shehzad Faizi, because without the cooperation and collaboration of our colleagues and our seniors, this could not be happened. I would like to sincerely thank the organizing team, moderator, and the technical staff from both universities who worked behind the scenes to make this event possible. My special words of appreciation for the distinguished speakers, Professor Dr. Fatima. I still remember I listened to her talk at UT, and it was, although it is not my subject, but still I enjoyed the talk and I learned something from her, and then I discussed with her as well. And I also thank Dr. Imran Talib, who is a wonderful colleague of mine, and he's a great speaker. I believe he will talk very good in this event, inshallah. And dear students and young scholars, I strongly encourage you to actively participate, ask questions, and use this platform to connect with experts. Such interactions can open doors for future research opportunities and international exposure. And in conclusion, I sincerely hope that this event will not a one-time activity, but inshallah it's a beginning of a long-term, sustainable, mutual partnership between UT and VU. And let us continue organizing such events in future as well. So with these words, I once again thank you all, and I wish you all have a productive session. Tarima Kasi and Salamat Pagi. Thank you very much.
Thank you very much, Professor Tanvir Hussein, for giving another warm welcoming speech. So, ladies and gentlemen, and our distinguished guests, we will now continue to the main agenda for today's event, the International Visiting Lecture with the theme of Global Trends in Mathematical Sciences, Research and Education Collaboration. In the session, we'll listen to the presentation that will be delivered by our honorable speakers, Professor Dr. Fatia Fatima, SSI MPD from Universitas Terbuka Indonesia, and also Dr. Imran Talib from Virtual University of Pakistan. And for this session, I would like to give attention to all participants who are joining us virtually for these following matters. First, please open your camera and turn off your microphone during this presentation. And if you have any question, please write it down to the Q&A section or chat box with the format your name, underscore your institution or UT daerah, and then followed by your own question. Or if you want to ask directly, you can click the raise hand button that already prepared on the Zoom. So, and once again, I would like to remind to all participants to fill the attendance form with the link that will be shared by the committee on the chat box at the end of this event. So, ladies and gentlemen, this session will be moderated by one of the lecturer from Mathematics Study Program, Mrs. Madadia Putri Martinasari, SPD MSc. Now, I would like to invite Mrs. Dia to guide us through an insightful lecture. So, Mrs. Dia, if you may guide this visiting lecturer, and the session is yours now.
Thank you, Ms. Safira. Can you hear me?
Yeah, it's crystal clear, Mrs. Dia.
Thank you, Ms. Safira, once again. Good morning, everyone. Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Namo Buddhaya, salam kebajikan, Rahayu. Let me introduce myself once again. My name is Dia. I am a lecturer in the Mathematics Study Program, Faculty of Science and Technology, Universitas Terbuka Indonesia. It is a pleasure to serve as a moderator in this visiting lecture, a collaboration between Faculty of Science and Technology, Universitas Terbuka Indonesia, with Virtual University of Pakistan. Today we have two distinguished speakers or lecturers, outstanding mathematicians, Dr. Imran Talib from Virtual University of Pakistan and Professor Dr. Fatia Fatimah SSI MPD from Universitas Terbuka Indonesia. We will have two sessions, one for each lecturer, followed by a Q&A session after the second session is finished. Now, let me invite and introduce the first lecturer who will enlighten us on modern strands in fractional calculus, theory, application, and collaborative research directions. He is Dr. Imran Talib from Virtual University of Pakistan. Good morning, Dr. Imran Talib. Can you hear me?
Yeah, Professor. Thank you. Good morning to everyone.
Yeah, thank you. How are you today, Dr. Imran?
I am well, Alhamdulillah, perfectly fine.
Yeah, nice to meet you, Dr. Imran. My name is Dia. You can call me Dia. I believe all participants are excited and looking forward to your lecture today. But before we start the presentation, please let me read your curriculum vitae first so our participants can get to know you better. So, ladies and gentlemen, Dr. Imran Talib is an assistant professor of mathematics in the Faculty of Science and Technology at the Virtual University of Pakistan, Islamabad, Pakistan. He obtained his PhD in mathematics in 2017 at the University of Management and Technology, Lahore, Pakistan. His academic experiences include being an instructor at the Virtual University of Pakistan from 2010 to 2017, a lecturer at the Virtual University of Pakistan from 2017 to 2023, and a visiting assistant professor at Minhaj University, Lahore from 2018 to 2019. His research interests include fractional calculus and applications, scientific computing, neural networks, and machine learning. He has already published 38 peer-reviewed research articles in international journals and contributed to international book chapters. I hope that sums up Dr. Imran's curriculum vitae. Now, Dr. Imran, are you ready to present?
Yeah, sure. Well, I'm ready. Let me share the screen with all of you.
Okay, Dr. Imran, we have 20 minutes for the first presentation, and to keep us on track, please allow me to notify you when the time is almost up. Thank you.
Okay.
Yeah, we can see it, Dr. Imran. Now the floor is yours.
Thank you. I'm very honored to present at the international webinar on current advancement in science and technology. My name is Dr. Imran Talib. I am a assistant professor in the Department of Mathematics at Bashar University of Pakistan. My research area covered three major areas of mathematics. One is scientific computing, where I have developed spectral methods which depend upon the operation matrix of orthogonal polynomials, and that are very highly numerical analysis techniques that have exponential convergence. And then the other core area of my research is that in neural network and machine learning algorithm, where we have developed the hybrid frameworks by combining the operation matrix of orthogonal polynomial with extreme learning machine techniques. And then by applying these methods, we have solved some particular type of fractional differential equation with various types of initial and boundary conditions. The other area of my research is fractional calculus and their applications, where we have developed some advanced algorithms to solve fractional order differential equation. We depend upon the operation matrices of orthogonal polynomials. And then this is a very key area of my research, where we have discussed the existence of solution of fractional differential equation under some conditions, whether the solution exists or not. And for this, we have used a classical lower and upper solution approach, which is a very famous approach in mathematics. The researchers who are working in existence theory, they are very much familiar with this approach. And then we extended this approach to extend it to fractional order differential equation by working with my PhD students, Dr. Asmat, who is also our colleague. And we extended this approach to fractional order differential equation. I have privilege of supervising and contributing in the field. Up to now, I have supervised 7 MS students and co-supervised 2 PhD students. I have published 40 research articles, including 2 book chapters. The theme of today's talk is modern trends in fractional calculus, where I will cover 3 themes: theory, how fractional calculus have been evolved over centuries; then application, how fractional calculus is being used across various disciplines of science and technology; and then some collaborative research directions. No, before going into the depth of my talk, I would prefer to discuss with you what is fractional calculus. Actually, fractional calculus is a generalization of classical calculus to non-integer order. Sorry, without limiting on the order 0, 1, 2, fractional calculus provide us the facility to extend the definition to non-integer orders like 0.5, 0.6, 0.7. Actually, the development of fractional calculus began in 1695 when Leibniz asked to the L'Hopital, can derivative with integer order be generalized to non-integer orders? Though in a reply, L'Hopital wrote to Leibniz, it will lead a paradox, but one day useful consequences will be drawn. So initially, this idea was just imagined that it was the curiosity of mathematician, and it was heavily used in pure mathematics. But in 1974, only one book was available on this idea, but in 2025, 240 plus books have been published on this topic, and thousands of articles are available on this idea. That shows the rapid growth and development of the fractional calculus, how fractional calculus are being used in various disciplines of science and technology. And that shows its importance in modern era, in modern research of mathematics. Now, we discuss some understanding fractional derivatives. Okay, why fraction calculus is very much important, and why 240 plus in last 2 decades 240 plus books have been published on this idea. There are main 3 key reasons. One is the memory effect. Some materials like polymer, rubber, biological tissues, and these materials have behavior like both solid and fluid. I mean viscoelastic behavior. When real materials show viscoelastic behavior, then they remember their past. So fractional calculus deal with the memory effects also, because suppose if working who are working in the physics, and they are very much familiar with the idea of Hooke's law. The Hooke's law is developed is usually used for the object of the elastic objects. But if we have a material like a polymer, like a biological tissues, then we observe that they have both viscous elastic phenomena. I mean to say that they remember their past. The behavior of the material actually depending on the past history of the then so integer order actually is not able to capture this memory effect. So the kernel that is introduced in the definition of the fraction derivative are used to store the memory. So it captures the memory effects. The other prominent aspect of the fractional calculus is in non-local behavior. In classical calculus, we observe that it works for just infinitesimal neighborhoods. In infinite neighborhoods, it only work at there. But when we want to capture the non-local behavior, for example, if we work, for example, consider the phenomena of heat conduction, and when we say that when temperature at a one point will affect the whole temperature in the metal rod. So there the time dependent behavior comes. So there we observe the non-local behavior. So fractional calculus actually captures the non-local behavior. So real world modeling, a fractional calculus is a very useful to model the real world phenomena. For example, if you work in a diffusion, and if, for example, add the case for the classical diffusion. When you work in the classical diffusion modeling, for there you can see that when the medium change from homogeneous to inhomogeneous, when there is a heterogeneous medium and the material is working in that, and we want to note the behavior of the material, then their anonymous diffusion comes. Though so integer ordered calculus cannot capture the anonymous diffusion phenomena. Also integer ordered calculus is not able to compute the viscoelastic behavior of some materials like polymers. So fractional calculus is very useful to model that kind of materials. Now look at three top the physical intuition. For example, suppose alpha is the order of the derivative. When alpha equals 0, then we have at the original function there no memory use and the full memory. The material is known what is used and what is happening at the right moment. But when alpha is 0.5, then the partial memory of the system is used. That is only able to capture by using the fractional calculus. So there the derivative is between a function and its first order derivative. And when alpha is equal to 1, then it's a classical order only. No memory use, only classical derivative is used. Let's understand this concept by a simple analogy. Suppose you are walking. So classical calculus taking whole steps. For example, you are walking on the stairs. If you take one step, you take whole step. Then you take second step, you take a whole step. Then when you take one step, it means it's order 1. And when you walking and take the 2 steps, then it means it's order 2. And when you are still standing there, it means you are at the order 0, where is alpha is 0. But in the fractional calculus, you can taking any size step smoothly. You can take 0.5, like understand this concept by visualizing the idea of by walking on a ramp. When you walk on a ramp instead of stairs, then you take fractional steps also there, 0.5, 0.6 and 0.7. So the fraction idea that smoothly work for a continuous pattern shows there. No, now we discuss about the theoretical advancement in fractional calculus, how the things happened in fractional calculus. The first very common, you can also say that is a pioneer fractional integral derivative operator. That's a Riemann-Lovely fractional derivative operator. Okay, lot of definitions today as depending on this idea that formulated and developed by Riemann and Lovely. Actually, the definition involve the integrals and the kernel function, and the kernel function are used to store the memory. The other definition of the fractional calculus is introduced by 1867 by Grunwald-Letnikov. This definition is based on finite difference approaches. Actually, these definitions are used when you work in the numerical analysis and you want to develop some numerical analysis with some accuracy. Then you use this kind of definition that is developed by 1865 by Letnikov and Grunwald. But this is a very famous source. After the development of the definition of a Caputo fractional order derivative, the rapid advancement happened in fractional calculus, because Riemann-Lovely derivative definition is not able to formulate the problem with integer order initial and boundary conditions. But when we work in a physics and some other applied areas of mathematics, then we need some physics. Okay, so Caputo first time formulated the differential equation problem with integer order initial and boundary conditions. So this result revolutionized the idea of fractional calculus, and fortunately Caputo is still alive and he's making contributing a lot in this area. The other definition, there's a Hilfer and Tagna-Bellino. These are the modern definition of the fractional calculus. Actually, Hilfer developed the definition by combining the idea of Riemann-Leibniz and Caputo. You can say that it's developed a generalized operator. But there is a one difference between this definition and the other's definition. In Caputo, the kernel that is used to store the memory is singular. In Riemann-Leibniz definition, the kernel is also a singular, but in Hilfer, the kernel is non-singular. In Tagna-Bellino definition, also the kernel is non-singular. That have some nice properties in groundwater studies. So before, there are 6 essential properties that when we want to check that with definition actually fulfilling the criteria of fractional calculus. First of all, linearity. It should be a linear operator like a classical operator. Index law should satisfy there. It is also called a semi-group property. It is also happening in classical calculus, and also this definition hold in fractional calculus. Then the left inverse is a very, very important properties, because when you develop the numerical algorithm by using spectral methods, then this left inverse properties of Caputo, Hilfer, and Riemann-Leibniz is very helpful in developing these algorithms. So VUP integration, then apply first differentiation, then apply integration, you get the identity. I mean, and then this is a limiting behavior of both Riemann-Leibniz and Caputo, and also Hilfer and Tagna. When alpha approaches 0, where alpha is the order of fraction derivative, then you have the original function, then whole memory. When alpha 1, you belong to the first derivative, yani no memory. So 0 order operator identity and first order operator, yani first derivative. So there are some open problems still there, because fraction like a calculus, like a classical calculus, fraction derivatives had not a unique definitions, because in classical calculus you have observed that you define derivative uniquely, but in fractional calculus there are many definitions available. First Riemann-Leibniz and Letnikov, Caputo, Hilfer, and Tagna-Bellino. So there are still some open problem in this field. It still is a very emerging problem, characterizing valid fractional operators. Okay, which fractional operator will be used in which scenario? Whether if you are solving diffusion problems, then which definition should be used? Either Riemann-Leibniz, Caputo, or a Hilfer. Standardized definition. There should some standard definition that will capture the phenomena of all viscoelastic materials, diffusion particles, groundwater studies. So bridging theory and application, because it's when you work in a fractional calculus, then there in the definition there involves, for example, in a Tagna-Bellino, they involve the Metac-Lafleur functions. Okay, so to solve analytically these kind of functions, and analytically it's a very difficult, challenging these days. So there is still room to develop some analytical results to solve differential equation analytically by applying the modern derivatives that like a Tagna-Bellino, because it's not easy to solve, because there is a kernel is non-singular, but there is a higher parameter Metac-Lafleur functions are involved there, so very tough to solve. So these are still open problems in fractional calculus. Interested readers may work in this area and get the benefit of higher impact factors publications. So now we look about some scientific and engineering applications. For example, viscoelastic materials. So visco and elastic. For example, some real materials are available in our universe that behave like solid and fluid. When they behave like solid, then they have elastic phenomena. When they behave like fluid, then they show a viscous phenomena, like rubber, biological tissues, rubber band, and polymer materials. These are all have viscoelastic phenomena. But classical Hooke's law, actually this is a stress, stiffness, and strain. Classical Hooke law actually is usually work for only pure elastic materials, that only solid materials, for example pure elastic materials. It does not work for the material that that shows the exhibit the phenomena of both viscoelastic. So if we take the fractional order time derivative of strain, then we have a fractional extension of a Hooke's law, of a classical Hooke's law. Then so this phenomena is able to capture the properties of the viscoelastic materials, actually, that show both behave like both fluid and solid. So when alpha is equal to 1, then this becomes pure Hooke's law, and so it is capture the hereditary effects. Hereditary effects means that, for example, when the polymer, when you have a polymer, then the polymer material also remember their past history. It remembers that how was it stretched, but the simple spring does not remember how it was stretched. So there are memory effect involved when material trying to learn how much they was stretching behavior, and they are familiar with their deformation history, then the hereditary effects involved, and fractional calculus actually efficiently capture this phenomena. The other is the phenomena is the anomalous diffusion. Actually, there are two types of diffusion actually exist. The person who are working in a fluid mechanics, fluid dynamics, they are very much familiar with classical diffusion and the fractional diffusion phenomena. Classical diffusion actually is modeled by Fick's second law. But first of all, what is diffusion? What is the diffusion? Diffusion actually is a phenomena in which the particle movement occurred from a higher concentration region to a lower concentration region, from where particles move from many ways to particles where there are few particles, where the less saturated area to less saturated area, the particle movement happened. That's the classical diffusion. But in classical diffusion, actually determined by Fick's second law, there the medium is homogeneous. Okay, the movement of the particle is smooth and gradual. Okay, the mean square displacement is directly proportional to the time. Okay, but when the medium is heterogeneous, not homogeneous, and the particle movement is not smooth, for example, the flowing of water in a porous rock, when the water flow in a porous rock, then they flow very quickly, then then there's super diffusion happen, not a classical diffusion happen. Suppose the pollen grains, look at an example, the pollen grains, when pollen grains move in water, then their movement of the particle happens very slowly, then their subdiffusion phenomena occurs that classical calculus cannot capture it. So there we have to look towards the fractional diffusion problems, actually, where the mean square displacement not directly proportional to the time, but the fractional power of time. So there some anomalous behavior capture this phenomena. There are some very interesting example of classical diffusion are, for example, the smoke of a cigarette in air is example of a classical diffusion. When the particle of ink dissolve in water, is example of classical diffusion. Okay, but when proteins move inside some biological cells, then there are the example of a fractional diffusion, because their super diffusion happen. That is only captured this phenomena by using a fractional calculus, actually, fractional order derivatives. The other scientific example is that circuit design, because we design a circuit to make the current from the circuit smooth. This is a classical capacitor where I is the current rate of change in voltage. The more the current, the more voltage happen actually there. So if you look at there is some relationship between a current and a voltage. More voltage pass, the more current will flow. Okay, so what is fractional capacitor? When we introduce the fractional derivatives and we take not the classical derivative and take the fractional derivative of the voltage, then what happened? For example, if you want to designing better filters, if you want to modeling the biological tissues, if you want to analyze the electrochemical system, if you want to prepare the better filters for the battery, then you have to look upon the fractional capacitance, actually, which is intermediate behavior between resistor and between classical capacitor, actually. So there's the strength of the fractional calculus that is much more important in this area, because where the movement pattern of the particles is not homogeneous, where you cannot capture both viscoelastic phenomena, and where you cannot capture the intermediate behavior between resistor and capacitor. So there fractional calculus comes. No. Next, we look is example, very hot area these days are machine learning, artificial neurons.
I'm
Actually,
sorry, Dr. Imran, we have around 2 minutes left. I'm sorry. Thank you.
I'm sorry. So I have to move quickly. Then these examples actually. Uh, so no, I will look is example in artificial neural networks. There are some neural networks. We have different neurons, that is input neurons, and there we have a header neurons, that the elements of the orthogonal polynomials. These are the computational units that is computed by using the methodology that is defined in there, where activation functions, actually these are the activation functions. So this is a network, there's a label output, that is supervised machine learning algorithms. So we'll show some results. This is a fractional order differential equations. When we combine the latest developed area with the fractional calculus, then you can see that we have a good results. Actually, these results that is obtained by operational matrix approach, and that results that obtained by combining the fractional calculus with the machine learning algorithms. You can say that it is highly computational efficient, absolute, highly also highly numerical efficient also. So there you can see that these are the results that is obtained by combining fractional calculus with the operational matrix. You can say accuracy is compromising there, but when you combine the fractional calculus applications in machine learning, then you can observe that the very resemblance between the analytical solution and the neural network solution that is obtained by combining the fractional calculus with the machine learning algorithms. And there is some kind of training logs. You can say that also in the residual loss, you can we train the neural networks by taking different neurons, 5 neurons, then 10 neurons, then at 50 neurons. You can see that a very promising results are obtained when you train when you train the neural networks by taking high neurons in the hidden layer. Similarly, same pattern and same phenomena is observing is there. So these are some global research landscape, some future directions. Actually, these are the application domain that have been already established. In fractional calculus, these are the emerging applications, that is still biological tissues where we work inside the cells, some genetics, some medicine. In biology, there is some resource modeling that is very hot area of today's disease research, where that's called the resource modeling. Okay, so most active countries, bar chart, time chart is there. You can see that these are the progressive countries and these are the less progressive countries in this area. And the future directions are there: numeric algorithm for fractional calculus, some interdisciplinary applications, some standardized operators, and characterized valid operations. These are the charting the future. Key trends, actually these are the key trends these days in fractional calculus, and particularly in mathematical sciences. Rapid growth across all scientific fields. Okay, expansion in biology, that's I working about resource modeling that is happening in biology and medicine and genetics, and integrating AI with machine learning, that I show some example with you how machine learning algorithms are embedding with the fractional calculus these days. Increasing international collaborations, you have the benefit. These are the challenges, actually challenges in fractional calculus and particularly in mathematical sciences. Standardized definition and operators, we do not have still in fractional calculus. It's still open problem. We do not have a standardized definitions and the operators. Development efficient numeric algorithm, that I am say that is a non-singular behavior involved in the definition of the fractional calculus operators. So there is still room in this area where we have to need to develop some efficient numeric algorithm. Bayesian theory and application, like that fractional calculus mostly dealt for the abstract mathematical idea without applications. But nowadays they are still challenges. Still still the modern operators like Atangana, Blino, Hilfer can be compatible to solve some type of real world problem, like the Professor Tangana has solved some application in groundwaters, and Professor Bellino also have solved in this area very much. Characterize valid fraction operator, this is a very challenging aspect. So which operator should be used where? For example, if you are working with a initial condition, then which operator should be used, either Caputo, Riemann Lovely, and which operator can capture the good memory effect and the hereditary properties of the phenomena. Opportunities, actually, they are still interdisciplinary research. There are some rooms in biology where resource modeling, some differential equations occurred. Like in fractional calculus, we have a room for this to start in this interdisciplinary research. Novel application in emerging field like neuroscience, like genetics, like biology, enhanced modeling of complex system. For example, some viscoelastic material which cannot be provide an accurate result by using a classical calculus. So there should be some room there. Global collaboration networks we also need. So conclusion, fractional calculus continues to evolve as a powerful tool for understanding complex phenomena with expanding application across scientific disciplines and growing international collaborations. These are international research collaboration. I am working with Professor Etagna, who's a founder of ABC Derivative. In USA, I am working with Martin Bohrer. We work on some numerical algorithms. In Turkey, I'm working with Professor Simal on the existence theory, Thabit Abdul Zawaj on stability theory, and Farouk Akhzar on some numerical algorithms. In Middle East, I am working with Thabit Abdul Jawad, and in Lebanon, I am working with Dimitru Belino on the numerical development of some algorithms. I'm finding new application in biological sciences. And in Bangladesh, I'm working with Professor MD Noor Alam. We are working on some partial differential equations numerically and analytically. And in Morocco, I am working with Zakia Hamouch, where we are working in the stability theory, existence theory, and the numerical application of some fluid problems. There's some European network where it's lot of research clusters, lot of opportunities are available. Some research, short-term research visits are available in Germany, in France, Italy, UK, because lot of these countries are very advancing countries in the area of fractional calculus. Okay, impact, what kind of impact of collaboration you get? Joint publication and conference, you can share expertise and methodologies, you can enhance your research skills, you can broaden your visibility. Okay, so these are the benefits of this collaboration. Yani cross-border collaboration accelerate discoveries in fractional calculus, bridging applications, theory, and modelings like that. These are sub-foundational literature. This is the letter that originated the idea of fractional calculus in September 30, 1695. And this is a very famous result by Caputo presented. After that, some revolutionary begins, and these are some books available. A very famous book of Paul Lubne, which enhanced the idea of fractional calculus in whole books. A very fascinating book. And this is a book of a Hilfer, who is a founder of generalized fractional operator. And this is a book of Balino, who is a founder of who joined work with Professor Intagna. He developed the founding result on the fractional calculus by defining non-singular kernels. This is the Caputo and Fabrizio paper. Fabrizio is also a very good mathematician. He working in fractional calculus very prominently, eminently, very prominent name. And Atagna, Professor Intagna, a well-known mathematician who have developed the idea of non-singular kernels in fractional calculus and have wrote many research and many books on this idea. And these are some of our recent publications. We have we have their work, Miss Danish Zaidi, she is also our colleague, and we are working on numerical stability and the existence theory of the fractional calculus operators like that. Thank you for your attention. And I'm very thankful to FST University Terbuka, Indonesia, for the invitation, and ORIC Department of Waseda University of Pakistan, who made this arrangement and disseminated the this invitation to our department. I am thankful to our HOD, Dr. Shahzad Faizi, my very favorite person, Professor Dr. Tanveer Saab, and I'm very thankful to you, Matlab. He is one of the guys to whom I like very much. Thank you very much.
Thank you, Dr. Imran Tarif. Very wonderful. And thank you once again for the insightful knowledge you have shared with us. I hope we can share more about this topic in the Q&A session with our participants. Now, please kindly wait for the Q&A session, and you may rest for a while, because now I will invite our second lecturer, Professor Dr. Fatia Fatima SSE MPD, to present the second topic today about N subsets and hybrid models for uncertainty-aware decision systems. Good morning, Prof. Fatia. Can you hear me?
Good morning. Yes, it's clear.
Okay. Yeah, I'm glad to be able to collaborate with you again now in this event. Like in the first session, please let me read the curriculum vitae first before our lecturer starts the presentation. She is a professor of mathematics in the Mathematics Study Program, Faculty of Science and Technology, Universitas Terbuka Indonesia. She is also the Partnership Development and Certification Manager at the Indonesian Online Learning Development Unit. Her research experiences include the development of Pythagorean multi-fuzzy and subset decisions and the development of data mining-based and soft decision-making sets. She has received several honors and awards like the Best Journal Article and the Outstanding Lecture Award at the Universitas Terbuka. Now, Prof. Fatia, we have 20 minutes for the presentation, and like the previous session, I will notify you later when the time is almost up. Are you ready, Prof. Fatia?
Yes.
Okay, you may start now. The floor is yours.
I think is it good? Okay.
Yeah.
Thank you, moderator, for the warm welcome. Distinguished colleagues from the Virtual University Pakistan, Universitas Terbuka, and guests, hello everyone, good morning and good afternoon. Thank you for joining with us. My name is Fatia Fatima, you can call me Fatia. Today I present and subsets and hybrid models. Let's begin with the most important questions. Why do we need another model? Let's start with the problem. The real world is granular, it's not binary. When we make a decision, we do not say yes or no. We do not see good or bad. We use ratings, we use levels, we use grades. But we are faced with the limitation of the tools. We have binary and afterwards loss of critical nuance. So the consequence, decision support systems that lack fidelity for the framework, for the fidelity in data. So models are misalignment with the expert judgment. Therefore, we need an imperative. We must build the system that mirror human judgment. We must build the gap between the uncertainty and the precision. So let's look at the history of this idea, just like Dr. Imran Talib. In 1874, we had the crisp set. This was a simple one-to-one correspondence. In 1965, Zadeh introduced fuzzy set. This gave us the membership functions. Then in 1999, Malotstoff introduced the subset. This introduced the parameters, binary collections of approximate descriptions. And in 2018, my team and I introduced the N subset. So what's the difference? N subset is graded structure. This brings us to the what? N subset paradigm is our answer for the previous question or problem. Formally, it's a trivial FEM that mapping, or that every object go to the unique grade from 0 to -1 for each relevant parameters. So it shifts our core questions from binary, like is it a member, to far more powerful, like what's the level does it belong? For example, is this supplier green? Yes or no? Or we ask, to what degree is this supplier green? We can grade from 0 to 5, for example. So how's the methodology? It follows simple for 3 key steps. First, we formalize the problem into an n-subset table, decision matrix of grades. The second, we do hybridization power. We fuse n-subset with fuzzy logic, for example, for smoothness between grades. With rough sets for knowledge reduction. And for the other one, indirectly multi-criteria decision making, for example, TAPSIS ranking. And the third step, we run into decision algorithm. We input the graded table and weights and then process via our chosen hybrid model, and we get the output, which is traceable, auditable with the transparent algorithm. Let me show you how the development of n-subset. N-subsets have had a global impact, particularly in the field of uncertainty mathematics. Here are some countries of researchers have been referred to our article n-subset. This is evidence that in the enthusiasm of international researchers in developing n-subset theoretically and practically. So I'll show you some of our researchers that have been collaborated and demonstrated the development of n-subset in theoretically and practically, such as incorporate lattice ordered structure and hypersoft topologies to handle multi-valued parameterization. And there were also hybridization for uncertainties such as fuzzy, heterosophic, bipolar sets, etc. And for the application, we can see from the other researchers that do the strategic decision making, such as promotion strategies for distance education, medical diagnosis, or etc. I just note about something that Dr. Imran Talib said, so I think it's so exciting performance. I need the slide, maybe, Dr. Imran Talib. So I just note one thing that you mentioned about design fractional, right? So I just come with the idea if we can collaborate about how to design fractional order and self-controller of where the grades or decisions using n-subset are based on accumulated historical sensory data. I just came up with that idea, so I just wrote in my note. So I'll show you the real-world problems that we propose in Universitas Terbuka. If this is an app, we name it TIA, Talent and Interest Allocations. This application based on n-subset decision-making algorithm. So this application helps students to identify their potentials. This application analyzes about the multiple intelligence, such as linguistic intelligence, mathematic logic, and visual spatial skills. So they will get benefit from the evaluation. So let me introduce our research group, if I may. So we call the name Keris Masif. It's from Bahasa Indonesia, Kelompok Riset Matematika dan Sistem Informasi. It means Mathematics and Information System research group. So this collaborative research agenda, you can see from the roadmap. Now we are in the phase 1, independent development with our topic. And then next in the phase 2, we want to integrate peace between AI, between our interest research to the massive decision support system to one unified decision platform. So in the next one, in the next phase, phase 3, we have autonomous system. So just like imagine health AI, logistic AI, policy AI, it can self-improving ecosystems. It can help themselves. So in conclusion, the why is clear, the what is established, and now let's collaborate on the how. Thank you for your attention.
Thank you, Prof. Fatia, for your lecture today about ANSOF sets and hybrid models for decision systems. I think that's all, everyone. Two wonderful presentations from our lecturers today. Thank you once again, Prof. Fatia and Dr. Imran, for sharing such valuable knowledge with us. Now I will start or move to the next session, the Q&A session, by inviting participants on Zoom to ask questions directly by turning on their microphone and camera. And please introduce yourself first by stating your identity, your questions, and the intended lecture. Any question, ladies and gentlemen? This is such a great opportunity to ask to our distinguished lecturers, Dr. Imran Talib from Virtual University of Pakistan and Prof. Fatia from Universitas Terbuka Indonesia. If you have any questions, you can turn on your microphone and camera. Or maybe if not yet, I will move to the chat box maybe first. Yeah, here there is a question from Vini Hukama in the chat box. Assalamualaikum warahmatullahi wabarakatuh. My name is Vini Hukama from the Mathematics Study Program at Universitas Terbuka. I would like to ask a question to Dr. Imran Talib. So this question is for Dr. Imran. How is applied mathematics currently contributing to real-world problem solving in Pakistan? And in your experience, how do universities in Pakistan collaborate with industry in applied mathematics research? Dr. Imran?
Hi, Professor.
Yeah. So do you need me to read it once again, or are you ready to answer it?
Yeah, I'm ready.
Okay. Okay, thank you, please. Oh, pardon me, Dr. Imran, you want me to read it once again?
Yeah, the questions I have to see in the chat box.
Yeah, from Vini Hukama, sir. My name is Vini Hukama from the Mathematics Study Program at Universitas Terbuka. The question is, how is applied mathematics currently contributing to real-world problem solving in Pakistan? And the second question is, and in your experience, how do universities in Pakistan collaborate with industry in applied mathematics research?
Actually, first I will entertain the second question, how the Pakistan is contributing in industry. And up to now, actually, in industry, we are lacking because we have not their central structure to contact with the universities, with the industries to use mathematics. But as the case for applied mathematics, we have very famous mathematicians who are working in applied mathematics area, like Professor Tasawwur Hayat. He's a very expert in fluid mechanics, and he's working very highly cited researchers, and he is contributing a lot. Currently, he is a professor at Kaiser University. The other sad is that my supervisor, Professor Dr. Ghazal Akram, who is working at Punjab University, he's working in biological sciences and a lot of problems in applied areas of mathematics. And some other researchers, like in Malakand University, we have a Professor Hamad, who is working in fractional calculus, and he has a lot of work in spectral methods and operational methods related activities. He has solved many diverse problems in this area who's directly related to the applied mathematics. Regarding the collaborations with Pakistanis are collaborating around the world in fractional calculus and in fuzzy mathematics. And in our universities, we have research groups of who are working in relativity theory, like Dr. Aisha Sadiqa. She is assistant professor there. She is working in the applied area. We have Dr. Usman. He is working also in fluid dynamics in the applied areas mathematics. We have a very young researcher there, Dr. Yusuf, who is a lecturer in our university. He's working in very diverse areas of applied mathematics, special theory of relativity. They are contributing a lot in applied mathematics. So myself also working in applied mathematics, we are solving some fluid problems. We are solving some we are developing some new numerical algorithms, like we have developed the operational methods approach there. Because there are non-linear analysis group, where we are working with Zulfikar Ahmed Noor, who is a lecturer, Miss Danish Zaidi, and Dr. Asmat. We are working in the fractional calculus area. We are touching some applied problems. For example, we are working in machine learning algorithms and developing some these kind of research in our universities also. I hope I entertained the questions. Is there any other questions?
Thank you, Dr. Imran, for your answers. Yeah, I think I hope that can answer your question, Miss Fini Hukama. Oh, we have one. Oh, oh, okay. Another question, maybe in the chat box, sir. Or okay, the questioner do not state who is the intended lecturer, but I will read the questions here in the chat box from Miss Tri Wijayanti Saptiarini. I am Tri from Universitas Terbuka. Thank you for a wonderful insight from speakers today. I would like to ask for both speakers. Okay, so she asked to both speakers from a practical viewpoint, what is usually the hardest part, theory, parameter identification, or numerical computation? Okay, I will invite Dr. Imran first, maybe to answer it. Thank you.
So sorry, I could not get the question rightly. Whether he's interested to ask about the numerical or scientific computing?
What is the hardest part? Is it?
Hardest part,
Yeah,
because
is it?
related to the talk, actually, the hardest part is that when you use fractional operators there, like Caputo or Tagnambalino, then they involve some complexities. For example, when you solve them analytically, then you have some type of metagalactic function which is too parametric, that is very difficult to solve analytically. Then their numerical methods provide us a oxygen and a room to solve such kind of hardest problems by using numerical algorithms. The real challenges come is the efficiency and the computational time, because when you solve the problems by using higher scale level, then their stability, I observed that the stability compromise there. Actually, for example, if you take the first 100 terms of orthogonal polynomials and want to approximate the solution on this, then you may observe that there's some time of stability issues occurs. But these stability issues that I resolved is by using by blending it with the machine learning algorithm. That was the last part of my talk. When you blend it with the machine learning algorithm, then you get that is very generic algorithms. So so the other issues, so computational efficiency are not compromising in machine learning algorithms, but in classical algorithm like spectral method, finite difference method, finite algorithm methods, they're at high scale level. When you solve the problem, then the stability compromises there, the solution not become stable there. Okay, the other hardest part is that when you use a spectral method for solving differential equation numerically, you observe that it lot of dependence on the operational matrices. For example, if the problem is modeled with the initial condition, you need two operational matrices. One is the derivative and the other is the integral in terms of Riemann-Leibniz. But when you formulate the problem with the boundary conditions, then you have to dwell some other operational matrices. Then the three operational matrices then involved in the numerical algorithms, definitely that compromise the computational efficiency. Similarly, if you have the non-local boundary condition like integrals or generalized non-local boundary conditions, and the problem is defined, if the nonlinearities occurs in the problem, then there are a lot of problems occurs where if the problem is nonlinear, and if the nonlinearity is in the solution function and also nonlinearity in the derivative terms, then you may observe that the simple numerical algorithm like the spectral methods, we have to linearize the problems there. That is a still difficulty. That is still open problems, because spectral methods still not very efficient to solve non-linear problems. They are very efficient to solve linear, whether partial, integral, or ordinary differential equations. But when you model the problem with nonlinearities, and nonlinearities if occur not in the solution, in the derivatives, then they lot of issues come. There's still open problem for the spectral method. You have to extend it to the nonlinear problem without linearize the problems. So they're the issues that I have observed while working in numerical algorithm and scientific computing.
Thank you, Dr. Imran. Such a very complete answer, but she asked two for both speakers, I think. So we will listen to another few points from Prof. Fatia, please.
Yes. Okay, thank you, Tri, for your questions. So I can say that it depends on your goal or your target. Let me share my last slide. I hope you can see. Can you see?
Yeah.
Yeah, good.
Yes, we can, Prof.
Yeah, this is some of and subset reference that I mentioned before. It's already more than 200 citation of this area from the overseas researchers. I believe Akram is from Pakistan also. I think University of something in Lahore, because he is my co-author also in our article. So I just want to answer the three questions. Akram mentioned about group decision-making analysis with complex spherical, fuzzy, and subsets. So the challenging here, I guess, it's about how to define the hybrid and subset with the complex spherical, fuzzy one. And also Akram and the other Alcantut from Spain, he mentioned about aggregation operator and multi-agent decisions with n subsets. So there are main objects about the multi-agent decisions, but Alcantut et al. Want to make sure about the aggregation operators. So in this area, it can be difficult about the parameters and etc. Ali, Demir, Musa, and many researchers can challenging about what they want to explain in just for 8 and 10 pages. Dr. Imran Talib know with sure that it's difficult for us to explain many things, because for us it's excited, but for the 10 pages we need to decide what's the priority, and that's the most challenging. And afterwards we want to divide which one we want to focus on, about the theory or about the parameter identification or about numerical computation in practical way. Thank you, Dia.
You're welcome, Prof. I hope that answered your question, Ms. Triwijayanti. And now we have one participant here who raised their hand, who raised her or his hand. Oh, we have two already. The first one from Rodney Faisal, Mr. Ronnie Faisal. Yeah, please. Mr. Ronnie Faisal, you can turn on your microphone. Mr. Ronnie? Oh, maybe it's the signal. Yeah, okay.
Yeah.
Yeah.
Okay. Thank you. Yeah. Can you hear my voice?
Yes, we can.
Yeah, okay. Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning and good afternoon. Um, I am the student of Mathematics of Faculty of Science and Technology UPPC UT Surabaya. My name is Roni Faisal. I'm interested in the research of Mr. Imran Talib about fractional calculus. So in this time, I would like to ask you about how can applied mathematics like fractional calculus provide immediate solutions to pressing global challenges such as climate change, pandemics, or financial instability. Maybe Mrs. Fatia also can give your opinions about my questions. Thank you, Mrs.
Okay,
Okay.
Professor.
You're welcome. Yeah, Mr. Imran, Dr.
Yeah.
Imran Salib, please.
Okay, Professor, thank you. Such a very interesting question. Actually, you know, the fractional calculus actually is a very natural phenomena. It's instead of integer order calculus. Okay, integer order calculus actually don't bother about the past, but in real life scenarios, you know, the past is very important. Okay, your present and very much dependent on your past contributions, and literature extension is also dependent on the past contributions. So memory effects are very important. So where as I highlighted in some applications like viscoelastic material, where I discuss the diffusion process, where I discuss about the circuit design, then you observe that in these applications, when we have a medium from a homogeneous to heterogeneous, then simple classical diffusions model that a classical fixed law is not applicable there. We have to look about their fractional modeling there, fractional version there. So when we compute the fraction derivative there, then we also care about the memory. And you know what happened at in some material like heat conduction in physics, you say that what happened at a one point, then it happened everywhere. For example, the temperature in a metal rod affecting the whole temperature in the rod everywhere in the temperature. This is a phenomena. So where you have a time dependent phenomena, where you have a memory dependent phenomena, and there you have more realistic modeling of the nature, then there is a very important to model these type of problem with the fractional derivatives. So fractional derivative actually resolve the issues related to the memories that classical calculus does not. It resolves the issues where the time dependent phenomena occurs, because in when we're working in the heterogeneous mediums, then you see that there even fraction derivative is not good, where a variable fraction derivative is variable. That is a modern development, and that is the derivative of the Tangna that is really defined there. That derivative resolve these issues. So they for example, so these type of conditions where memory comes, where heterogeneous medias come, where time dependent phenomena comes, then there you have to model the problem with the fractional calculus, not with the integer order calculus. I think, Professor, it's fine, or you have more question, more discussion, then you are welcome.
How about it, Mr. Ronnie Faisal? Do you want to ask more, or is it enough? Oh, you are not turning on your microphone yet. Maybe it's the signal. Okay. Okay, I hope that answered your question. Okay, how about Prophetia, do you want to add something? No?
I think it's fine as long as the climate changes we can evaluate from multi-valued and multi-criteria decision making, it will be okay. So it's nice idea about the climate changing.
Thank you for both lectures. Now, another question from Mr. Firdandiko Andi. Yeah, please state your name, maybe UT daerah, and your questions and the intended lecture. Thank you. Mr. Firdan, please turn on your microphone. Okay.
Thank you for the opportunity this time. Can you hear me, Professor or Doctor?
Yes. Yeah.
Thank you. I have a question about are there probability if mathematical science or fractional calculation that can be combined with biological sciences in the future? Example, we can create a robotic AI or in the agriculture, something like that. Are there probability combine twice knowledge? Thank you.
So is it to Dr. Imran, right?
Yeah, hello, dear, your question is related to is that can we combine the fractional calculus with the mathematical biology? Is that type question you are? So regarding if you because there are many papers are available on this idea where fractional calculus dealt the biological system in neuroscience modeling. There are many papers, Professor Balino, Professor Etagna, and Professor Ravi from India. These guys have worked well in biological modeling of these papers. So it's already a developed idea, and fractional calculus is using a lot in these areas. So you may find many papers of Professor Bellino, Atagna, and Professor Ravi.
Yeah, thank you, Dr. Imran. So it's already collaboration of that, right? Yeah,
Thank
Mr.
you.
Firdan. Okay, you're
Thank you, Dr.
welcome.
Indan.
Thank you. You're welcome.
Okay, I think this is the last question from participant who raised their hand. The last one is from Zubaida Safiq.
Assalamualaikum. Am I audible?
Yes.
Yes.
Okay. My question is for Dr. Fatia. My question is that as far as I understand, the fractional calculus is between the non-integers between 0 and 1. I want to know that how the decision making or the fuzzy logic is between 0 and 1, or the number in again the integer other than 0 and 1. Dr. Professor Fatia, have you got my question, or I need to?
Yeah, I guess I got it.
Yeah, okay, thank you.
Okay, thank you for the question. Yeah, that's the interesting one for the ends of set concept or paradigm. We combine with the other uncertainty mathematics framework. So for the example, we know about the fuzzy set, right? It is between 0 and 1, it is a real number. So when we combine with the n subsets, we name it fuzzy n subsets. So what we do? So we evaluate the parameters based on the objects using n subset, but we want to make sure about which one is the member and which one is not a member. And the interesting one, sometimes we want to add the hesitancy. So such as a fuzzy hesitancy and subsets. So based on the evaluation the expert, we want to know what's the grade of the hesitancy that the objects belong to one parameter, for example. Or the other expert want to share about his value in what's the parameter that not in I mean he know exactly the value or the grade without any hesitation at all, but the other expert, he has hesitancy and he has the membership and non-membership. So we want to gather the evaluation because everyone's matter, right? So we don't want to lose the information. So maybe you can check the reference about n subsets. There are many researchers that collaborate the idea about the grading and with the other uncertain mathematical theory. Thank you. I hope it's okay for you, Zubaida.
How about it, Miss Subaida? Is it answered your question? Or maybe we lost connection, Prafatia. Yeah, I think we need to move to the chat box. We have two more questions, and because of limited time, I think we can answer only these two questions. The first one from Chandra, Mr. or Miss Chandra. Assalamualaikum, I am Chandra from UT Batam. I would like to ask a question to Dr. Imran Talib. Can the Caputo and Atangana fractional derivative definitions be applied to the modeling of fractional differential equations? And how do they differ in representing memory effects? And to what extent do modern numerical algorithms contribute to the effective solution to fractional differential equations and the expansion of fractional calculus research? Is it clear, Dr. Imran? Do you want me to read it once again? Yeah.
So thank you.
Okay.
Such a wonderful question he asked, actually, related to the memory effect. Yeah, you are asking about, interested to know, can the Caputo and Tagna fraction definition be applied to modeling of fraction differential equations? How they? Yeah. These are very realistic definitions. One is the old definition, and the other one is the latest definition, actually. Regarding the modeling of the Caputo derivative, because before Caputo derivative, there was some pioneer result that about the Letnikov, who definition of based on limit base, and other was the Riemann Lovely, whose definition was integral base, actually, which have singular kernel. Okay, but these definition related to the Adagna, related to the Riemann, this definition was not able to model the problem with initial with integer order initial boundary condition. You know, when we model the problem, then when we model any physical problem, then we are interested to capture the physical part of the problem. Okay, so then in 1967, the Caputo developed a fractional operator. That then the first time the integer order initial and boundary condition was formulated in the problem, and they explained the physics of that. They started to explain the physics of the problem. That was the rebirth, in my point of view. That was the rebirth of the fractional calculus that Caputo provided to this area, because after that, lot of biological models and lot of other physical problems was solved
using the Caputo fraction or derivative operator. Regarding the memory effect, that differ by in those, to capture the time dependence and memory behavior, the Caputo derivative is not well able to capture the memory effects of the anomalous diffusion problems. If your medium is heterogeneous, for example, a water flowing through porous rocks, or proteins was dissolving into the human cells, there the Caputo derivative is not well able to capture the phenomena. Then that was the reasons of the development of the Atagna operator. He tried to capture the problems in the groundwater studies. In diffusion problems, he is well able to slow down. Also, there is some very important attribute is that the compatibility of the Caputo operator is not accurately with the Riemann level integral, because the Caputo definition is wholly dependent on the Riemann level integral operators. But this integral is not compatible with the Caputo. But the integral that defined by Atagna is purely compatible with this definition that is defined with non-singular kernels. So these are major difference and major breakthrough regarding the Atagna-Blino operators. So the other question is that to what extent do modern numeric algorithms contribute to the effective solution of fraction differential equations, expansion of fraction calculus? Yes, they are contributing a lot regarding the fraction calculus, because the modern algorithm is that we have some classical algorithm like spectral, finite element methods, but no, the modern algorithms are truly dependent on the machine learning algorithm. No, the fraction calculus is finite space in machine learning, in deep learning, okay, in neural networks. As in last slide I discussed, where fraction calculus find the room to contribute in machine learning algorithms. So they are blending with the machine learning algorithms, where the activation function are using some metaglacial functions, some orthogonal polynomials, and by then how the question is that like how we transform then the differential equation into some simple algebraic system of equation that is solved by using machine learning algorithm that like extreme learning machine algorithm, that is a gradient free algorithms. So they the role of these numeric algorithm, in what way they are blending, they are transforming the problems into a system of equations. Then we solve by using these some machine learning algorithm, also some quantum computing algorithm. It's a very much important role of quantum computing algorithm these days. In this way, fraction calculus is making room, finding space in diverse areas of machine learning algorithm these days.
Thank you, Dr. Imran. And one more question for you, Dr. Imran, in the chat box. In expanding the horizon of fractional calculus research, we are seeing a growing integration between neural networks and differential equations. In your expert opinion, will these data-driven approaches become a strategic partner to traditional numerical methods, or could they eventually replace them in finding effective solutions for fractional equations in the future? Specifically, how do you see the role of statistical learning in addressing the computational complexity of fractional memory effects? Thanks.
Thank you. Actually, still no, I did not work in statistical and data analysis, but fractional calculus actually is using in these areas also, where we train the data by using some machine learning algorithms, and we predict the behavior of the material, or whether that behavior material with the viscoelastic or some type of that, like whether it's a solid or a fluid. So these are recently I saw a paper on a statistical analysis where some detailed memory effects of by applying some techniques, statistical technique, data driven technique, they analyze the memory effects of the. So if you have my email, then I can send you that paper directly. This is a very relevant paper if you're working in statistical analysis. So in their fraction calculus are truly combined in the used to learn the data analysis and train the data analysis. So I can send this paper to you directly. You may find it very interesting and very helpful to you.
Thank you, Dr. Imran, very kind of you. And because the two previous questions are for Dr. Imran, I think I will open one more question for the session. this is the last one from Uswatun Hasanah to Profatia. Please correct me if I am mistaken. As far as I understand, the N subset was mainly developed for ordinal data because it considers the order of attribute values. My question is, can N subsets also be properly applied to nominal data? If yes, how should we define the grading without imposing artificial order? Please.
Thank you, Uswatun Hasana. We meet in the online session, right? So, yeah, that's interesting question. You know already, and you read our article, and subset is kind ordinal number. But if I may say something to you about the nominal data, we can choose this is nominal or ordinal. So it's based on your purpose, such as color. Color, it's kind of nominal. If Uswatun say like that, if she says so, red, green, black. If you ask me, I maybe will change it to the ordinal one, reddish. So what's the level of red? Because if I choose my hijab, it is kind of red. This is just the low of red. We know black, many kind of color black, right? So black, just brown black. So it's depend on our target or our goal, which one we want to stress on. If the data only nominal, you can grade it, it's okay, don't do it. But if the data still can grade your grading, you can use N subset. So even N subset is general of subset. So if you want to categorize the data, the nominal data, you can use the simple one, which is 0 and 1. But if you want to complex, you can use the nominal one, and then you put the grading for that objects. I hope it's helped for you and for the other. Thank you, Dia.
You're welcome, Profatia. Yeah, ladies and gentlemen, because of limited time, due to time constraints, we have to end this session. But I hope this is not the end of our communication and our collaboration. And I hope this event can initiate other projects in the future. So everyone, we have arrived at the end of this event. I would like to say thank you for the opportunity, and I apologize for any mistakes I made during this event. Moreover, I would like to express gratitude to the Faculty of Science and Technology, Universitas Terbuka, Virtual University of Pakistan, and other parties involved who made this collaboration possible. Now, let me close this by saying Parama Santi, Om Santi 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 Om. Wassalamualaikum warahmatullahi wabarakatuh. I hand it back to the MC, Miss Safira. Thank you.
Okay, once again, thank you, Mrs. Dia, for guiding us through an insightful sessions. And we would like to say thank you again to Professor Fatia Fatimah and also Dr. Imran Talib for sharing such an insightful knowledges relating through our visiting lecture theme today, Global Trends in Mathematical Sciences, Research and Education Collaboration. And as a token of appreciation, next, we will see the ceremonial of delivering certificate to our honorable speakers. For the first certificate, will delivered to Professor Dr. Fatia Fatimah, SSI MPD from Universitas Terbuka Indonesia, and this digital certificate will be delivered by the Dean Faculty of Science and Technology of Universitas Terbuka. Please, Dr. Subekti Nurmawati, MSI.
Okay, thank you, Ms. Safira. On behalf of the Faculty of Science and Technology, Universitas Terbuka, we would like to express the deepest gratitude for Professor Fatia Fatima, who present the material is very, very important for us and very useful. Hopefully inspire to all of us. Once again, thank you, Prof. Fatia.
Thank you, Bu Dekan, Bu Din.
Okay, thank you, Dean of Faculty of Science and Technology of Universitas Terbuka, Dr. Nurma, and also Professor Fatia Fatima. And the next digital certificate will be delivered by the Director of Auric Virtual University of Pakistan to Dr. Imran Talib from Virtual University of Pakistan. Professor Tanvir Hussein, are you there?
Yeah, thank you very much, Safira. Congratulations, Dr. Imran Taleb. You delivered a very nice lecture, and I believe this collaboration will further extend. And I'm grateful to the Dr. Fatia Fatima as well. She talked once again very nicely, and I listened to her talk as well. And congratulations, and thank you very much.
Thank you, Dr. Imran,
Thank you.
for your presentation. Is hopefully which inspire us. You has deliver about the mathematics as a role of the basic science for other science. Yes, we can enhance our collaboration.
Thank you. You're welcome. It's pleasure to me. Thank you.
Okay, once again, we would like to thank our honorable speakers, Professor Fatia Fatima, and also Dr. Imran Talib. And we would like to say thank you to the principals of the Virtual University of Pakistan and also Faculty of Science and Technology of Universitas Terbuka, who are already supporting the committee to help this international visiting lecture. And next, ladies and gentlemen, we will have a photo session together, and I would like to ask to all of the participants who are joining us virtually through Zoom to open your camera. We will have two photo sessions, two times of photo sessions. The first one with the formal pose, and next we will have salam ute. Salam ute, you gotta have to use the U with your right hand and T with the left hand. Yeah. Is there any symbol that we can represent the Virtual University of Pakistan, Dr. Imran Talib or Professor Tanvir Hussein?
PU.
VU. Okay.
Yeah,
Okay.
PNU.
Okay. So for the first one, we will have a formal pose first. So once again, I would like to invite to all participants to open your camera, and I will do the countdown from 3, 2, 1. Okay, and then we gotta have a salam ute pose. U with the right hand and T with the left hand like this. Is it possible? Okay, I will do the countdown from 3, 2, 1. And I guess VU pause. UV, VU. Is it correct?
UNV.
UNV, okay. VU, okay. Okay, so we will do this pose in 3, 2, 1. Okay, once again, thank
Okay,
you
thank you.
all. So, ladies and gentlemen, we have reached the end of today's event. On behalf of the committee and the whole faculty, who's coming from Universitas Terbuka and also Virtual University of Pakistan, we would like to extend our gratitude for all of the speakers and all of the participants for your contributions on this event. And also, I would like to remind to all of the participants of today's event, don't forget to fill the attendance form by clicking the link that already shared by the committee on the chat box. And we hope that today's event become a great experiences for us all here to share knowledges, experiences, and inspirations. And Hope to see you again on another visiting lecture. My name is Fira. Thank you. Have a good day. See ya on the next visiting lecture session. Bye-bye.
Bye bye everyone. Thank you
Bye-bye.
so
Thank
much.
you.
Terima kasih, Mbak Safira.
Terima kasih, Bu Dekan. Professor Tanfir Hussein and also Dr. Imran Talib. Once again, I would like to say thank you.
Thank you very much, Ms. Safira. You conducted very nicely, and also the other moderator, Miss Medj Dia.
Mrs. Dia.
Mrs. Dia.
Thank you, Mr.
Thank you once again,
So,
Dr. Nurmawati, and I could see
Pleasure.
Miss Elizabeth Novi as well. So,
Oh,
hi, Miss Elizabeth.
yes, Elizabeth Novi. Oke, Mbak Dia, terima kasih.
Sama-sama Ibu, izin live ya.
Ya, oke, makasih.
izin
Izin
live,
live
Ibu.
juga.
Kamu masuk tadi?
Negeri elok amat ku cinta, tanah tumpah darahku yang mulia, yang ku puja sepanjang masa. Karena airku aman dan makmur, pulau kelapa yang aman subur, sejak dulu kala.